Hello student, welcome to AriserTalent. I'm your math teacher Arpita Sharma. Okay students, so I've told you that this lecture will be the last lecture of our chapter 2 and that's polynomial. Okay, so starting with the name of this chapter, polynomial. I have told you guys to solve a question and here it is. Obtain all other zeros of 3x raised to power 4 plus 6x cube minus of 2x square minus 10x minus 5. If two zeros are root 5 by 2 and minus root of 5 by 3. Sorry, it's root 5 by 3 and minus of root 5 by 3. So, how will solve it? Given zeros, so that will be 5 by 3, okay, root 5 by 3, negative sign. So, by this we can conclude easily that two factors are this. Now, I have given you this hint that you will use this formula of a square minus b square equals to a plus b multiplied by a minus b. Okay, by this formula we can write this as x square, right, minus of 5 by 3. Now this can again be written as what? That will be 3x square minus, okay, 5, 3x square minus 15. Okay, so that will be 3x square minus 5. So now we'll get this factor as one factor of 3 or say polynomial x. Let us assume this polynomial x. So call it that factor, this particular 3x square minus x is a factor of px. Okay students. Now we just have to divide it because we have to obtain all other zeros. So do the division process. That's, let's write this in this manner. We have got this. So 3x square minus 5. This is what? Our gx. Okay. So now we'll be having gx square minus 5 here and 3x to power 4 plus 6x cube minus 2 of x square minus 10x and minus of 5. Now as I have told you, the maximum degree is here 4. So write 3x to power 4 here. Now 3x square. Okay. So 3x square. Now cut it short and it will give you x square. Okay. Now you have to multiply that x square with this. So do this here. 3x square minus 5. 3x square minus 5 multiplied by x square will give you 3x to power 4 minus of 5x square. So copy this here. 3x to power 4 minus of 5x square. We'll write it here just below x square term. Minus of 5x square and this x square here. Okay, now change the signs. minus and plus. Okay. Now remaining 3x cube plus of 5x plus of 5x square minus of 2x square will give you plus of 3x square, then minus 10x minus 5. Okay. Now 3x square and 6x cube. Do it again. 6x cube upon 3x square. This will give you what? 2x of positive sign. Okay. Plus 2. That will give you 2x multiplied by 3x square minus 5. That will be 6x cube minus of 10x. Okay. So write it here. You will be getting plus of 2x here and 6x cube minus 10x here. Okay. Now minus and plus cancel out. Now 3x square and this remaining minus 5. Now 3x square will give you what? Plus 1. So here 1 multiply this one by this, we will get the same term. So write it as it is. Now change the signs, cut this, you have got the remainder equals to 0. So my dear students, I have told you, if the remainder is 0, that means this and this, your divisor and your quotient, are factors of your dividend, right? So we can say that 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5 can be written as x square plus 2x plus 1 multiplied by 3x square minus 5. Okay. Now this 3x square minus 5 is already having its own factors, which are x minus root 5 by 3 and x plus root 5 by 3. Now what about this term, x square plus 2x plus 1? So multiply this by this coefficient of x square and that constant term. So you will get 1. Okay. So how can you write 1 multiplied by 1 and 1 plus 1 equals to 2 and 2 is here. So how can I rewrite it? I can rewrite it like x square plus x plus x plus 1, right? Now again up to here we'll write the same, and here we'll get x common, okay. So we'll get x plus 1. Here by getting 1 common we'll get x plus 1 again. Now that will become x plus 1 and x plus 1. Now we have factorized it, so we can easily see that polynomial zeros of polynomial are plus of root 5 by 3 minus of root 5 by 3 minus 1 and -1. So this is the required answer. Okay, note it. I am going to rub this now. Okay students, so as I have told you, we have covered all the types of questions and the complete theory part of this chapter, polynomial. So now we are going to have a recall for that. Okay. So I am going to tell you that what we have studied so far in chapter 2 polynomial, and I will conclude this particular chapter today, right? Okay students, so we have studied chapter 2 polynomials. In this chapter, first we understood what polynomial is. Okay, so we discovered the part term that was having two parts, number parts and variable part. Then we understood that this number part is called as coefficient, and the variable part can again be divided in these two parts. First is variable, which is x, y, z or any alphabet, and the second is exponent part. Okay, we'll call this part as exponent, right? Then we have specific names for polynomial like mononomial, monomial, binomial, trinomial and polynomial, which is having respectively 1 term, 2 terms, 3 terms and more than 3 terms. Okay, now we have done some examples of polynomial expression, and we discovered that this is polynomial, this is polynomial, this is polynomial, and this is not somehow a polynomial, and this is somehow not a polynomial, and this is a polynomial but polynomial in more than one variable. Okay, so we discussed and we know the difference between a polynomial expression and a non-polynomial expression now. Okay, then we find out the degree of polynomial, which was what? The highest degree was termed, you can say highest power of the expression, polynomial expression was termed as the degree of polynomial. Then we have divided this in 3 categories: linear polynomial, when you got the highest degree as 1, then quadratic polynomial when you get highest degree as 2, then cubic polynomial when you get highest degree as 3, then zeros of polynomial. Here we understood that at particular value of k, if px is 0, then this k is known as zeros of variable, zeros of polynomial. Okay. Next, we understood these graphs. In these graphs, we have seen that the number of times a line passes through this x-axis, that particular number of times is the exact number of the zeros of polynomial of that particular expression. Like in this case, this line is not passing through the x-axis and not cutting it, so we identify that we are not having any zeros of polynomial in this particular case at all. In this case 1, in this case 1, 2, 3. Okay, then we discussed possible cases for quadratic polynomial. Before discussing this, we have also discussed some case of linear. In that case, either it can pass through one point of x-axis, or maybe that the straight line may be parallel to x-x axis. In the first case, we will be having 1 zeros of polynomial, and in the second case, latter case, it will have no any zeros of polynomial. Now, in quadratic polynomial, we found that this upward or downward parabola can be here. Now, it can either cut this 2 points being upward or downward, or it can only cut at 1 point. So, this will have 2 zeros of polynomial, this will have 1 zeros of polynomial, and we are also having this type where this line is not touched by the parabola, either upward or downward. In the both cases, we will be having 0 zeros of polynomial. Okay, then we considered same for cubic polynomial graph, and we find out that we will be having at most 3. We can have it up to 2 or 1 also. Now, we have read relationship between zeros and coefficients of a quadratic polynomial, where we find out that sum of zeros equals to minus coefficient of x upon coefficient of x square, and we also wrote it like this, minus b by a, and multiplication of zeros or product of zeros equals to constant term, that was c, and coefficient of x square, that was a. We have read these formulas also. Next, we also studied relationship between zeros and coefficients of a cubic polynomial. If alpha, beta and gamma are 3 zeros of cubic polynomial, then we find out that sum of zeros equals to coefficient of x square upon coefficient of x cube. Then product of zeros, we find out that it was equals to minus constant term divided by coefficient of x cube. Right, students? Then we studied division algorithm for polynomials. It was something kind of division lemma. Okay, Euclid's division lemma. It is for polynomial, and that was for numbers, and this is for polynomials. Okay. So, this is the complete class we have studied in our chapter 2. Okay, students. So, as we have discussed in our slides, we have covered the complete course here of chapter 2. Our chapter 3 is again about linear equation, but it's 2 linear equations. Okay, till now we were only talking about an equation. Okay, and now we will be talking about 2 linear equations. Look, why these equations are very important. So, when we will go through this complete chapter, we will get to know that very daily routine types problem can be solved with the help of these type of equations. Okay, so if I am having 2 kind of equation and I am having 2 kind of variables, I can solve them somehow. Okay, we have done this kind of things in previous classes also. Okay, students. So, in our next chapter, we are going to do the same with some problems, and even these problems are related to our day-to-day life. So, it's gonna be a fun class, right? So, students, I am concluding this chapter 2, polynomial. Now, what you have to do, you have to read it thoroughly from your textbook, do some exercise, do some questions, because whenever you will do some questions, you will be doing number of questions, then you will be knowing that where you are lacking. Okay, so when you will know where you are lacking, you can cover that part. Okay, students, keep watching. Thank you.